Right, on to question 3. Question 3 is a mix of a hyperbola and a parabola, and so it's probably going to be a little bit more tough than question 1 and 2. And it says sketch below is f, which is your hyperbola, and g, which is your parabola. The asymptotes of f are shown. E is the x-intercept of f and g. Okay. The y-intercepts of f and g are c and d respectively. B21 is the turning point. Now alarm bells should go off then. If you have a turning point, that's wonderful. And notice they gave you the formula in the turning point format, so that's great. And it lies on the intersection of the asymptotes. So immediately I can see that x is 2 will be my vertical asymptote, and y is 1 will be my horizontal asymptote. So let's have a look at the questions. What is the domain of f? Now f is your hyperbola, and so hopefully it's a very common question. Hopefully we'll realize that x can always be anything except our asymptote, and our asymptote is at 2. Okay, write down the values of p and q. Well, p and q are in the formula, so let me just go and write down my formula quickly. My formula is f of x equals 1 over, now I moved 2 units right, so that'll be x minus 2, and then I moved 1 unit up, so that'll be plus 1. Now just be careful because it depends on what formula they gave you. They gave us 1 over x minus p plus, oh no, that's not in the right place, plus q. So it's fairly obvious to see that q is 1. So q is 1, but the value of p, it could be negative or positive. It depends what they gave you as the formula. They gave us x minus p as the formula. So x was given, the minus was given, and that must be p. So p is actually 2. They could make the formula 1 over x plus p. So the sign that they give you is completely random. We need to know what the sign must be in order to create this movement, which was right. So in this case, p had to be 2, so that my formula read x minus 2. Okay, determine the coordinates of e. Now they told me what e was. E is the x-intercept of the both of the functions. Now I don't know the x-intercept. I can't work out the x-intercept of the parabola, but I can work out the x-intercept of my hyperbola. So my hyperbola is 1 over x minus 2 plus 1. To find an x-intercept, I make y 0. Don't forget that the first important thing is to figure out what you're actually trying to find. So now that I know it's my x-intercept, I've made y 0. I'm going to multiply by x minus 2 on both sides. So I get negative 1 x minus 2 equals 1. Let me just show you what I've done there. I've multiplied by x minus 2 on both sides. And so now I get minus x plus 2 is 1. So negative x equals negative 1. X must equal 1. Now just be careful. Have we answered the question? The coordinates of e. So e would be 1, 0. Just make sure we answer the question. Now does that look plausible? Well, yeah, it does. We never draw to scale, so I'm not looking at it to see if it looks plausible from, guesstimating a scale. I'm just trying to see, oh gosh, it should be positive and it should be less than 2. So that makes sense. Now, just out of interest, it means that I can actually figure out the other x-intercept of my parabola, because it's 1 unit to the axis of symmetry. So from the axis of symmetry, it'll be 1 unit over. So that'll be at 3, just out of interest. Okay, next question says determine the values of a, k, and m. Now we were told that the parabola was a x, let me just go check, x minus k squared plus m. Now that's the turning point formula. Now that doesn't mean we must automatically use the turning point formula, but in this case it kind of does, because I was given the turning point. So I immediately know that it's going to be a, and I moved 2 units right, so it's minus 2 squared, and I moved 1 unit up. So immediately I can tell you that k must be equal to 2 and m must be equal to 1. Again, notice the minus was in the formula, and so I don't need k to be negative. There was a minus already given. So all I needed to do now is to solve for a. but I have a point. I've just worked out that this is 1, 0. So always draw in what you find out in each question, because sometimes it's useful in the next question. So I now know that y is 0 when x is 1. So it's 1 minus 2 squared plus 1. I minus 1 on both sides. And this is negative 1 squared. And negative 1 squared is 1. And so a is equal to negative 1. So does that make sense? Well, this is a sad parabola, and so it does make sense. Right, moving on. Find the length of CD showing all your working. Now, I'm not too sure if you remember what C was, but C was the y-intercept of the hyperbola, and D was the y-intercept of the parabola. Now, just to note that CD means a vertical distance. Now, we did quite a lot of vertical distance questions in the parabola and straight line questions, and vertical distance is always equal to top y minus bottom y. So the question is, can I find the top y? Well, I can, because it's the y-intercept of the hyperbola. So my hyperbola was 1 over x minus 2 plus 1. So to find my y-intercept, I'm going to make x 0. So it's 0 minus 2 plus 1. I'm going to use my calculator, and I'm going to get a half, which makes sense because it has to be less than 1. So I know that C is the point 0, a half. Okay, now to find D. D's coordinates are fairly easy as well. I know that the parabola is minus 1x minus 2 squared plus 1, and I'm going to make x 0. So it's 0 minus 2 squared plus 1. Again, I would use my calculator, but I get negative 3. So I know that D is the point 0, negative 3. So therefore, CD is fairly easy. Top y is a half, minus bottom y is negative 3. So careful, it's minus 3. And if I use my calculator, that gives me 3.5, or 7 over 2, or 3,5, all the same thing. Perfect. So that was practicing our vertical distance question again. Right, on to the next one. Give an equation of the axis of symmetry of f, which is the hyperbola, which has a negative gradient. So the hyperbola has two axes of symmetry. It's the one that goes up with a positive gradient, and the one that goes down with a negative gradient. Now they wanted our negative gradient one, which is minus x plus c. So first way to do it is to know that the axes of symmetry go straight through the point of intersection of your asymptotes. So I'm going to sub in the point 2, 1 into y equals negative x plus c. So 1 is negative 2 plus c, and c equals 3. So my axis of symmetry is negative x plus 3. Or there is the other method to do it, and the other method is to say that your original axis of symmetry would have been negative x. So whatever transformation happened to your graph, the same as happened to your axis of symmetry. So I'm going to move 2 units right and 1 unit up. So that's negative x plus 2 plus 1, which is negative x plus 3. So just pick which way works for you. You'll notice that these axes of symmetry questions come up a lot. They're very common. Right, moving on. 3.7. Give an equation of the function of h if h is the reflection of g about the line y equals 1. Now, what does that mean? Basically, this is my graph of g, my parabola, and I want to reflect it over the line y equals 1, which happens to be the asymptote. So if I reflect it, that's what will happen. Now, g had equation negative 1 x minus 2 squared plus 1. So the question is, what has changed here? Have I changed my turning point if I fold this graph over that line? And the answer is no. Have I made it a happy graph? The answer is yes. So h of x will actually be positive 1, which means you don't actually have to write it. X minus 2 squared plus 1. Okay, moving on. For which values of x is g, which is your parabola, greater than or equal to your hyperbola? So when are the y values of the parabola greater than or equal to the y values of the hyperbola. Don't forget, you always have to interpret the question first. Now, remember, I've said this a couple of times, an inequality question always has nothing to do with doing it algebraically and everything to do with the graph. So you want the parabola to be above the hyperbola. So I use my ruler and I start on the left-hand side and I say, right, which graph is above? Now you'll notice your parabola will be all the way down here. So if I move my ruler across, my hyperbola is above, my hyperbola is above, my hyperbola is above, and all of a sudden at E, they're equal to each other. And after that, if I keep my ruler going, my parabola is above, my parabola is above, until I hit this asymptote, and then all of a sudden my hyperbola is above again, because now my hyperbola has flipped to the other arm. So now hyperbola is above, hyperbola is above, hyperbola is above. So actually, none of the green is what I want. All of the green I can delete. So it's from E, where the graphs meet each other. Then what happens is my parabola is above my hyperbola until the asymptote. At the asymptote, the hyperbola flicks to being above again. So that is one interval. It's from E to the asymptote. So x must be bigger than something but less than something. It must be bigger than the E value, which was 1, but less than the asymptote, which is a 2. So it's between that. It's one interval, hence your inequality is one interval. Now just be careful, when can we include things? The question says, when is it greater than or equal to? So it's equal to each other at E, so I can include E. I cannot include the asymptote because the hyperbola is not defined at the asymptote. And so you can't say that the parabola is above the hyperbola because the hyperbola isn't even defined. So I can include 1 because they intersect at 1, but I can't include 2. It's quite a tricky question. The next question is also quite tricky. I'm not too sure we've seen one of these. This question said, when is the hyperbola's y value times the parabola's y value less than 0? So the question I always ask myself is, how do you multiply to get a negative? Because this question is saying, I want to multiply these two y values to get a negative. So what signs do you have to multiply? You would have to multiply a positive sign by a negative sign in order to get a negative value. So I need to say to myself, I need y values of opposite sign clearly. That's what I'm looking for here. So again, this has nothing to do with algebra and everything to do with reading from the graph. So you first need to interpret the question. I need my y values to be of opposite sign. So again, if I start with my ruler, what signs do I have here? This y value is above the x-axis, so this is positive. This y value is negative. Now, Doogie, that's good. So positive hyperbola, negative parabola. Positive hyperbola, negative parabola. So this entire time they're different signs, different signs, different signs, until they're both equal to 0. Now, the question said it wanted to be less than 0. At E, both the y values equal 0. So I can't include E because 0 times 0 would be equal to 0, and that's not included. So basically what I've learned so far is anything below E is acceptable. So as long as x is less than 1, my graphs were of opposite sign. Now what happens after that? Oh my word, they're still opposite sign because the parabola and the hyperbola have swapped. So they're still opposite sign, that's still fine, all the way to the asymptote where the one graph isn't defined. So, or you can actually include anywhere from 1 all the way to 2. So from E to this asymptote is also acceptable. The only thing is I couldn't include the 1. So that's why this is written as two separate things, simply so that I can exclude the 1. Now I can't include the asymptote, but what happens after the asymptote? After the asymptote, I've got positive, positive. Now that's not ever going to multiply to give me a negative. So positive times positive, positive times positive, positive times positive, until one of them swaps again. And that happens at the other x-intercept of g. Because after that, I'm going to have a positive hyperbola, but a negative parabola, and that's what I want. So anything after that intercept over there, so or x must be greater than, and the question is, what is the other intercept? Now, I'd actually already said to you, just out of interest, I'd found it by symmetry. Now, this is only a 3-mark question, so they don't want you to actually go and find that the long way. They want you to see that E happens at 1, the axis of symmetry is at 2, and so this intercept is at 3. So, or x is greater than 3. Now, the reason why it's only 3 marks, even though it's quite a lot of thinking, is that you either kind of understand this concept or you don't. And so to make it any more marks would be a little bit unfair. This is probably one of the toughest questions, is this whole idea of when the two y values multiply. So try and interpret the question before you read off the graph what they want. We definitely need to try some more of those in the mixed past paper questions. Okay, I think this is the last question for question 3. It says, for what values of t will g of x equals t have no real solutions? Now, we've done these ones before in the parabola questions. So when will the parabola equal to a constant have no answers? So if I draw on a random constant, so if I draw on a random horizontal line, that line intersects the graph twice. This line intersects the graph twice. And any line here is going to intersect the graph twice. Where is it going to intersect the graph? Once, at the turning point. Remember what we learned last time is that these types of questions always center around the turning point. Now, anything above that turning point and your constant graph will never hit your parabola, which is what you want. So any value above there for t, I'm not going to have any solutions. So those values are t is greater than 1, where our asymptote is. Right, that was quite a toughie. It's the moment you bring a parabola into anything, it tends to become a little bit more complicated. So well done on that. We've got 3 more questions to go.